All right, so we're on exam 4. Let's take a look at number 5. So, given the function f of x equals negative 2x minus 2 on the interval negative 4 to 3, find the area using different methods. Okay, graph it and find the area under the curve using geometry. The way I did this was first, I marked the interval, so that's going to be negative 4, and that's going to be 3, right? And then now let's graph this. So, it's going to have a y-intercept of negative 2. It's going to go down 2, and then over 1, down 2, over 1, and then down 2, over 1, right? Then we're basically going to do the same, just going up. Just graphing this line normally, right? Awesome. So, now what we want to do is we want to find the area under the curve, right? So, from here to here, right, this area here is going to be made up of, or to find this, we just do basic geometry. So this is 4, then this goes to 8, so this is 32 divided by 2, and then so the inside of this is going to be 16. And since we're finding net area, it's going to be negative 16. And for this, right, the area under here is going to be made up of a height of 6, length of 3, and that's going to be 18 divided by 2, which is going to be 9. And so 9 minus 16, that's going to equal negative 7, and then units squared. All right, so for 5b, we're going to be using integration, right? So first, let's write the integral. So it goes from a to b, so let's do negative 4, negative 4 to 3, and then let's put our function in there, right? And then next step is just to integrate. So that's going to be negative 2x 2 over 2 minus 2x. Awesome. Now let's simplify. Oh, don't forget this. Now let's simplify this. Just negative x squared minus 2x to 3 minus 4. So to find the area, you're going to do f of b minus f of a. F of b is going to be f of 3. So let's put f of 3 in there. Negative 3 squared minus 2, negative 3. I mean, just 3. Right? And this could be minus f of a, which is going to look like negative 4 squared minus 2, negative 4. Awesome. Now let's solve for this. So this is going to be negative 9 minus 6 minus, so this is going to be positive 16, but then it goes negative again. Positive 16 minus negative 8. All right, and so let's keep going. 9. So this is going to be negative 15 minus, this is going to end up being plus, so it's going to be negative 8. So it's going to be negative 15 plus 8, which then again is negative 7 units squared. All right, on to part C. We're going to be finding the exact area under f of x using the definition of an integral, which is all Riemann sum. All right, so first, let's write down the definition of an interval. The definition of an interval is going to be the limit as n approaches infinity, and sigma notation for n and I, f x I with delta x. Awesome. We also know that delta x equals b minus a over n. So let's find what delta x is. Delta x equals 3 plus 4 over n is 7n, right? Now, xi equals a plus delta xi, right? So let's figure this out. Xi equals negative 4 plus 7 over ni, right? Now, fxi, we're going to put anywhere we see f of x, right? So negative 2, negative 4 plus 7 and I minus 2, right? So now let's distribute this out. This is going to be 8 minus 14 and I, right? And then this is going to be minus 2. And then let's combine like terms. 6 minus 14 and I. Now that we have everything, let's plug it all in, right? So let's start with limit as n approaches infinity, right? And then sigma notation, fx of I is going to be our 6 minus 14 over ni, and then delta x, which is going to be our 7n. All right. So from here, we can move this before the sigma notation because it's a constant. So let's do that. Get it out of the way. And 6 minus 14 and I. All right. So now we can apply the sigma notation to each individual inside. So lim as n approaches infinity, 7n, right, to I equals 1, 6 minus 14 and I, right? So since the constant rule applies here, it's just going to be 6 times n. It's going to be n times whatever goes here. And I rule applies here only once we move this constant out in front of this sigma notation. So let's apply first the constant rule. 6n, then now let's move the 14n in front of the sigma notation, and I equals 1, and then I, right? And then with I rule, we can figure out what this all equals. And so the limit as n approaches infinity, 6n minus 14 over n, and then this is where I rule applies, n squared over 2 plus n over 2, right? And then now let's distribute this 14 in to each of these, or the 14n squared. So n to infinity, 7n, 6n minus 14n squared over 2n plus 14n over 2n. And then this and let's not forget our parentheses here. All right. So these n's cancel out, and then this just turns into 7. So the limit as n approaches infinity, 7n, 6n minus 14n over 2 And this, let's just simplify that all the way down to 7n. And let's make sure we also distribute this subtraction sign here. And this is just going to be 14 over 2. Awesome. Now we want to distribute this 7 into the entire equation, right? So let's shrink all of this so that we have some more room to work with. All right. So when you multiply all this in, it's going to look something like this. Because it cancels out, because the ends cancel out, the first one is going to be 42, and then the ends cancel out for this one, so it's going to be 49. And then minus, it's going to be, again, just 49 over n. Because this is just going to be 7, so 49 over n, right? And now let's apply our limit n. So it's just going to be 42 minus 49 minus 49 over infinity. And a number divided by infinity is going to be like a really small number. So let's just say that this is just 0, right? And now when we solve it, we get negative 7 units squared.